Okay, now I will start because I don't know how up to how long it will continue. So, but at least whatever is possible, it can be done. There are certain more things which regarding the previous parts, that is your Range Kutta methods. I have to. Okay, let us see that if I can do that in the end, I will try to do that. There are two things actually. One is your some Range Kutta methods of second order, the names and all the things. So some I have written that I have taken from your book RK SRK Iyengar book, numerical solutions to ODE rather. PD is now separated one. So that I will show you later on, because that file I am not able to open. Otherwise, in the end, if I will try from my desktop, if it is possible, I will show you. Another thing is that the fourth order implicit Range Kutta method, which I am not going to derive, because that derivation will be exactly, it is along the same line as we have done for the second order, but the length will be too high, so I am not going to derive that. But the one problem I will, the same problem you have to do with that, I will explain if it is possible today, because if it is possible to open the file, then I will go for that. So meanwhile, I will move to the another part, that is your some more multi-step methods. I have already informed you people earlier that you please revise that your interpolation. So we'll use that interpolation thing and proceed further. So let us first take the attendance, otherwise very few people are there. So, and then I will move further. Got it stuck. Okay, let us see. So the problem is your y prime equal to fxyx. We simply integrate this from xn to xn plus 1. So it will be your yn plus 1 minus yn. I hope now you understand the meaning of all these things. This is your y of xn plus 1 minus y of xn equals integral from xn to xn plus 1 ft yt and then dt. Now, this we may write because y prime is f, so this is same as your xn plus 1, xn to xn plus 1, your y prime t dt. Now, what we'll do here, basically, this is y prime is a function of t, so we'll try to replace this, or the in other word, if I say the actual mathematical word, we'll try to approximate this function as a polynomial. Let me first remind a bit of the things from your interpolation. What you do in your interpolation, can anybody tell me? Anybody can tell me? Quickly, tell me anybody.
Hello, sir.
Yes, tell me.
Hello, sir. Sir, heard that you attended other prof wasn't, so we couldn't join.
What I am asking, first you answer that.
Sir, I just now joined, sir.
No, you should join beforehand. Why you are joining at this stage?
It is our fault that we had another class from 3 to 4 and the prof did not leave us. So we had to join, and still he's speaking to class.
You
I
see,
left
you
that.
see, you see, because of that, why should we suffer? So
Yes,
wait,
sir.
wait.
He told that.
Leave that. First you leave that. You have to join early. First thing. That we'll talk later on. That is a different point. What I have asked, first you answer that, if you have the answer. Aman, do you know the answer? Now you have muted. Now you are not talking. So why should I include your attendance?
Sir, I did not even listen to the question because I joined late. I just now joined.
I have just told the question. So it is Shetty. What is your name?
Vardhan, sir.
Vardhan.
Yes, sir.
Okay. So do you know this interpolation? It is already taught to you in Mass 1, Mass 2.
Yes, sir.
Yes,
sir.
Okay. So what we do there? Tell me that. So again the question is there. Quickly tell. I don't have much time today because there is a problem in MS Team. Yes, quickly tell me. Again you have muted. So your attendance will not be counted. Okay. So no, don't tell all these things. Don't tell nonsense things. Anik?
Again, sir, I was trying to answer and I've been muted and removed from the team.
I haven't done anything. It is. Anik? Anik Mandal? Where are you?
Hello, sir. Am I audible now? Yeah.
Vardhan?
Interpolation is.
No. Yes. Now I want to talk to Anik Mandal.
Okay, sir. Yes.
So you are Vardhan. So wait for that. Anik Mandal? Anik Mandal? See the situation. What you people are doing, it is very clear. Aditya Jha? Akash Chandra?
Yes, sir.
Akash Chand, Aditya, I will talk to you later on. Akash Chand? Okay, Aditya.
Yes, sir.
Can you tell me what you do in your interpolation?
Sir, in interpolation, there is basically a given set of data. Let us say input is given and outputs are given, and we have to find, as per the question, we have to derive the value or the output of particular input, whether the input can be within that particular range or out, like interpolation or output.
Wait. That you have told me what you have done numerically. Okay, let me ask further. Suppose there are p+1 number of points.
Yes, sir.
So how will you do that? Or what type of thing you will get there? Do you get the polynomial? Let me give the hint. Do you get the polynomial?
Yes, sir. If there are p+1 point, then we can get a order accordingly that order of polynomial.
So it is, if it is p+1 points are there, then how many? What will be the order of the polynomial?
Sir, p+1, like the order of the polynomial can be p plus 1
No,
or
not at all. Not at all. Vardhan, now tell me. Vardhan.
Sir, hello.
Hmm?
Sir, like interpolation is nothing but basically plotting on a graph and then the and
No,
then
not
the
at all. Not at all. Not at all. Don't tell all these things. Anybody else?
Sir, we'll get an n
Sir,
degree polynomial.
p degree polynomial.
Yeah,
P
sorry.
degree. Okay, Adrija. Okay, you get the p degree polynomial, right? And the property is that it is matching with those points. Yes or no?
Yes, sir.
Okay. So what we are going to do here is that we will approximate this function y prime using a certain number of points to a polynomial of appropriate degree, means as many as number of points we'll take, we'll get some polynomial. Adrija, did you tell that what will be the degree of polynomial? I think if it is p plus 1 points are there, then what will be the degree of polynomial? Highest degree of polynomial will be less than or equal to p. Is that?
Yes, sir. Yes.
If it is p plus 1, you can get even beyond that. What is the trouble? This must have been taught to you in your interpolation.
So actually, if we are forming the equation with p plus 1 points, maximum p plus 1 points are there, so p plus 1 unknowns can be find out. That p plus 1 unknown comes when the highest degree of polynomial is p. If it is greater than p, then there are more number of unknowns, like greater than p plus 1 unknowns. So if that much point is not available with us, so we can't find all the unknowns. That's why the maximum polynomial which come out is p.
No. Okay.
Sir,
Okay,
polynomial
wait.
polynomial.
Wait. You, since you have raised this question, let me explain this. Otherwise, there will be. I mean, all these things should have been taught to you in your maths one. Must have been taught. Whether you have learned which way, I don't know. So, suppose you have got a for p plus 1 points. Suppose you have got a polynomial of degree p. Write down any name. Let us say hx. Hx is a polynomial of degree p. Right? Yes or no? Have you written?
Yes, sir.
Okay. And the points are suppose x1 to xp plus 1. Points are
x1 to xp plus 1.
xp plus 1. Right? And this polynomial hx polynomial has the property that h of xi should be hi, the point which is given to you. Is that or not?
Yes, sir.
Okay. This is true. This must be true for I equal to 1 to p plus 1. Right?
Yes, sir.
Okay. Now, with this polynomial hx, you write down another polynomial gx. Write down gx equal to hx plus, have you written hx plus c times, you have to write the product which I am going to tell. C means any non-zero constant. X in the bracket x minus x1, then x minus x2, x minus x3, and so on up to x minus xp plus 1. Have you written? Adrija, you also?
Yes, sir.
Okay. Now see, this polynomial Gxi is also Hi. Yes or no? For all I.
Yes.
Huh?
Yes, sir.
What is the degree of this polynomial? You see the product part. Degree of the polynomial is p plus 1, while hx is of degree p only. Hx is of degree p only. But the product part which you have added is of order p plus 1. Is that or not?
Yes, sir.
Now, so what will be the answer then? We have got a degree polynomial of degree p plus 1, which satisfies the same properties as h are doing. So what you were saying is not correct. In fact, it is the this way that since it is true, the gx polynomial is true for any constant c, so this polynomial will not be unique. So you will get a unique polynomial of one degree less, in the sense that if the p plus 1 number of points are there, then you'll get a unique polynomial. If you don't get the unique polynomial, you will be in trouble, because which polynomial then you have to take? So you will get a unique polynomial of degree p. Is that clear to everybody? Is that clear to
Yes, sir.
everybody?
Yes, sir.
Yes.
So never do any mistake. Otherwise, there was no meaning that I should proceed further, because this is. And do you remember that Newton's forward and backward formula? Do you remember that Newton's forward and backward formula? No, forgotten. Anyway, I'm just going to tell you. So this y prime t will approximate by a polynomial, appropriate polynomial, and depending on that, and then after that we'll integrate it. So certain coefficients will come and so on and so forth. So depending on as many as points we'll take, and in the order we'll take the point, the polynomials will change, and then integration will change, and the whole thing will change, and then accordingly we'll see that that different names of the methods are coming. So let us see first one. First one, we will take the p plus 1 number of points. So it is very obvious. So what we are going to, here it is written, let ppt denotes the polynomial of degree less than or equal to p, by which we are going to approximate this y prime t. Y prime t is also a function of t. So which interpolates y prime, means we'll take the points xn minus p to xn and interpolate this y prime at these points. Since it is xn minus p to xn, so it will be the most convenient thing is that we take the points in a reverse order, that is your xn minus 1 and up to xn minus p. So if we take the points in the reverse order, we apply basically Newton's backward difference formula. I hope this must have been taught to you in your Maths 1, Maths 2. Without that, numerical analysis will not be completed there. So we'll first write that how that PPT will look like. So the formula, the backward formula is like that. The point, that is your yn prime at the point n, plus t minus xn divided by h, that the step length, the difference between xn xn plus xn and the two consecutive one. And this is your backward operator yn prime, that is your, how do you define the backward operator fxn? Adrija, how do you define the backward operator fxn?
Sir, it's the difference of
Fxn minus 1. Is that right?
yes, sir. Yes.
Okay. So how will you get the del square? Del square of fxn.
Del
It can-
fxn minus Del fx
So it
n minus 1.
it can, yeah, so it can be written as del of fxn. So which is basically del of fxn minus del of fxn minus 1. So and then again you write that values. Is that right? Is that right?
Yes, sir.
Okay. So the backward formula is written as your t minus xn by h del yn prime, because the point is your function is yn prime, y prime. So it is not f, I'm not writing. So and then t minus xn, next point t minus xn minus 1 divided by 2 factorial into h square del square of yn prime, and like that. Next, if you want to write, that will be your t minus xn minus 1, t minus xn minus 3 divided by 3 factorial, and then h cube and del cube backward operator del cube yn prime, and so on. The last point will be t minus xn to t minus xn minus p plus 1. Here the points are xn minus p. So it will be up to p minus 1. Up to p minus 1 means xn minus in the bracket p minus 1. In the bracket p minus 1 means it is your xn minus p plus 1. So up to this, the product is taken divided by p factorial s to power p, and then backward operator del to power p yn prime. And the error term will have all the products. Error term will have all the products of this type. So it will be your t minus xn minus 1. We just, after this lecture, you people should see the revise that. If you haven't revised the interpolation, especially the backward Newton's formula. So t minus xn minus 1 and so on, t minus xn minus p, all the products are there, divided by p plus 1 factorial. Here h part is not there, and then y prime to power p plus 1 xi is there. Y prime the p plus 1 derivative of y prime at the point xi, where xi is a point from lying between your xn minus p to xn. So all these things you have to revise. This is what is already taught to you in your Mass 1, Mass 2. So, so the error term will be written as y, instead of y prime p plus 1th derivative of that, we write that yp plus 2. That is very obvious. You understand that. And the point t lies between your xn minus p, because xn plus 1 also comes in the picture once you integrate it. So that also is taken care of here. So and y2 is obviously, it has to be p plus 2 times differentiable, otherwise you cannot write this. Now, you might have read in a different form that I will show you. So now, as I have said, that after writing the interpolating polynomial or approximate polynomial for your y prime, we will just integrate it from xn to xn plus 1. So this is the next job. So we have approximated this y prime t by ppt. So that ppt I have written with the error term. Error term is written separately. And next we'll integrate this from xn to xn plus 1. So the first term is integrated. Second term, since y prime at the point tn or xn will be your fixed point, the constant value, so it can be taken out. Similarly, this backward operator del y prime n, del square y, all these terms can be, except for the term which depends on t will be inside. So it is your xn to xn plus 1 dt, plus inside the integral next term is xn to xn plus 1 t minus xn dt, and next it will have the two terms into dt, and so on and so forth. Now, These are the things which were done in your, must have been done in your Maths 1, Maths 2, that how you can see the another form of that. So anyway, doesn't matter whether it is told or not. So basically, we'll just put the substitution t minus xn as h into s, and then dt will be your h into ds. So this t minus xn will replace by that, and dt will be replaced by h into ds. Immediately you can see that as t goes to xn, s goes to 0, very clear from here. And then if t goes to xn plus 1, s goes to 1, very obvious from here. Is that right? Is that right?
Yes, sir.
Is this clear, or anything else is required to be explained? Any doubt till now?
No, sir.
Anybody? No doubt. Okay. So you see that t minus xn we have taken as hs. So t minus xn minus 1 can be written as t minus xn. Inside the bracket it should have been minus h, but outside the bracket if you see it will be plus h. So we may write h s plus 1. So this t minus xn minus 1 will be written as h into s plus 1. So now we'll just see the integral. So the first term, which is your dt is your h into ds. So that h will be out. So here h yn prime, and then 0 to 1 ds is there. Similarly, you put the values here t minus xn. So that will be your h into s. Dt is again h into ds. So this will be your h into h squared divided by h. So it will be basically h will be left here. So again the h will be out, and then delta y prime n is there. Similarly, you write down the other terms, that t minus xn minus 1 if you see here. So it will be your t minus xn is hs, and this will be your h into s plus 1. Third one is h into ds. So the h square is here. So it basically again you get h will be out. So basically you will see the following form. This is very simple thing, 8th standard thing. The only thing is that, so it is, you are getting h yn prime. The first integral is 0 to 1 ds. You may assume here 1 into ds. That will be better to understand. Next is your h, backward operator del yn prime 1 dot s dot ds, into ds, plus h squared, the backward operator del square yn prime 1 by 2 factorial, that is already there, and then 1 s, next one is your s plus 1 and ds, and so on. So this way it will be there. So let us define these integrals. Gamma naught, let us take as 0 to 1 ds, or rather I will say that 1 into ds. Gamma 1, you take one more term, so it will be 0 to 1, 1 into s into ds. Gamma 2 will be 1 by 2 factorial, 1 s, s plus 1, next term, and so on and so forth. So this way, if you see the general one, the gamma j will be 1 upon j factorial, 0 to 1, 1 s, s plus 1, s plus 2, and so on, s plus j minus 1 ds. So this will be your, if with this gamma j's, we'll see that xn to xn plus 1 ppt can be written in the first, if you see, this is your gamma naught, h into gamma naught yn prime, h backward operator del y prime, this is your gamma 1, and so on. Here it is gamma 2, so like that. So it can be written as h gamma equal to j equal to 0, summation j equal to 0 to p, gamma j del to power j yn prime means for j equal to 0. This is gamma naught, operator to power 0 is 1, so it is yn prime. Then next plus, it is your h del backward operator del yn prime gamma 1, and like that the next terms coming automatically. One thing you have to be very careful. One thing you have to be very careful once you write this your gamma j as this means gamma naught will be the only first term, that is your 1 by 0 factorial, and then 1 into ds. Gamma 1 will have the two terms, so it will be 1 by 1 factorial, 0 to 1, 1 in 1 dot s ds. The next will be gamma 2. This will be 1 by 2 factorial. So the three terms will come, means 1 dot s plus 1, and like that. So this way this gamma j is defined. So whether this definition of gamma j is clear to everybody?
Yes.
So if you do a little mistake, means everything is gone. And keep this mind what we have taken as hs, or rather s. So integral xn to xn plus 1 ppt dt equal to h into j equal to 0 to p gamma j delta j, the jth power of our backward operator, and then yn prime. And then we have to see the error part, how it looks like. Error part was tn plus 1, xn to xn plus 1, and then your all the terms are there, all the products are there, divided by p plus 1 factorial, p plus 2th derivative of y at a general point psi. Oh, this I have taken the direct one, so okay, there is a trouble. Oh, both are like that. Okay, let me see another file. Since I'm not able to open the file, so I have done some the other way too. Just wait, I am trying to open the file. Now whether this slide is, I mean, you can see this slide on your screen. Yes?
Yes, sir.
It is in blue ink. The another slide it is. Adinija?
Yes, sir, it is visible.
Okay, good. Then I will somehow manage the thing. These are the general thing which was written. This is already told to you. Okay. So here is, that was clearly done, but anyway, it doesn't matter. So t minus xn to xn to xn plus 1 integral, whether it is integral xn plus 1 or something else, I think it is there. So integral xn to xn plus 1, and then t minus xn to t minus xn minus p, exactly the same way you have done for the term by term integrals. So we'll put that t minus xn as hs, t minus xn minus 1 as h into s plus 1, and then like that. So it you can put that, and the way we have done those things, that coefficients, the individual terms, exactly same way you can write, and then you can integrate this. So that will do depending on the order of the method. So it is your if you see this s to power p plus 1 is there, so and then h into ds is there, so the total s to power p plus 2 will be out, and then remaining, if you take that h out, then this will be your nothing but your gamma p plus 1, and then that is written gamma p plus 1 s to power p plus 2, and then p plus second derivative at the point xi, right? Is this clear? Is this clear or not?
Yes, sir.
So how will you do? You will do that by just as it is done earlier, that t minus xn is put as hs, then t minus xn minus 1 as hs into p h into s plus 1, and like that. And then once you write that, automatically we will see that every term has h terms, so it will be h to power p plus 1, and then one extra h is there with your dt, because dt is your s times ds, so it will be s to power p plus 2, and this whole thing will be written as this. And then your the truncation error, the local truncation error, can be written as gamma p plus 2 s to power p plus 2 y p plus second derivative of y at the point psi. This method is called your Adams-Bashforth method. This method is called Adams-Bashforth method. One thing you already know, if the local truncation error is of order for any thing, it is p plus p, let us say general one, it is of order p plus 1, the method will be of order p. So here it is p plus 2 is there. So I think the last slide has that part which I wanted to tell you. Hopefully it is there, otherwise I have to open another. I think it is there. No, it is not. Okay, let me see the other slide. Okay. Ajay, whether this slide is directly seen, or the old slides are seen on your screen? That blue ink. Adrija?
Sir, now the screen is visible where we can see the icons, our
Only
faces.
icons are there. Only icons are there. Okay. ठीक है, I'm again doing that. Now I think another is that Adams-Bashforth order 1, order 2, like that it must be there.
Yes, yes, sir. Yes, sir.
Right?
Yes, sir. Yes, sir.
Okay, now, so at least something I can explain. Now, for p equal to 0, there it was local truncation error. It was s to power p plus 2. So if p equal to 0, so this will be of order. Local truncation error will be second order, so order of the method will be 1. So if you put in that, I'm just because I cannot show it here, so I will just read it, and then Where is that? Which way I should explain? That is the basic trouble. Okay, let me go back to again that previous one which I have shown you. Okay. Adrija,
Yes, sir.
the slide from which I was teaching initially, is that slide is seen?
Yes, sir.
Okay. So I think now that it is your h into yn prime into 0 to 1 ds is there, right? The first term. Yes or no?
Yes.
Okay. So you take your register, everybody take your register and write down. Take your register and write down. On the left hand side, what are the terms are there? We have integrated from xn to xn plus 1. So everybody should write, please write that, otherwise it is not possible to show all the slides. Write down yn plus 1 minus yn. Write down yn plus 1 minus yn. Together I will show you, don't worry. Write down yn plus 1 minus yn. Have you written that? Have you written that? You please respond, otherwise it won't be possible for me to. Yes?
Yes, sir.
Okay. Now on the right hand side, you will write this integral value, that is your h, yn prime, gamma naught. First one is gamma naught. So h, yn prime, gamma naught. Gamma naught is, okay, first you write down.
Integral 0 to 1 ds.
Okay. 0 to 1 ds value is what? 1?
1.
Yeah, right. And what is gamma 1 also? You calculate that also immediately. Gamma 1 is s square by 2. Limit from 0 to 1. So it is
Half.
1 by 2. Right? Okay. So so what is on the left hand side? We have written yn plus 1 minus yn equals h yn prime, because gamma naught is 1. Right?
Yes, sir.
Is that right?
Yes, sir.
What will be the error term then? This is corresponding to your P equal to 0. So P equal to 0 means what? P equal to 0 means what? You see, here it is yn plus 1 minus yn equal to h gamma naught yn prime. Next term will be your gamma 1. Next term will be your gamma 1, and the power will be, because P is your 0. It is gone. Oh, it cannot be shown here. Oh, that's basic trouble. Okay, error term I will tell you later on. Error term I will tell you later on. So on the, so what will be the final one? It will be your yn plus 1 equal to, you take yn on the other side, write down yn plus 1 equal, rewrite that, yn plus 1 equal to yn plus hyn prime. Yes or no, for p equal to 0?
Yes, sir.
So what is this? Which method is there? This one.
Euler method.
Euler method, not Euler, Euler. Euler method, right? So the error will be very obvious, that error will be of order h square. That I will explain you. If not, if it is not possible today, maybe next time I will explain that clearly, that part. Okay. So this is there. Now, can you if you take the next term also, that is p equal to 1. First term you have already seen, gamma naught yn prime. What will be the second term? Second term will be
Half of h into
half of h, and then backward operator del yn prime. Right?
Yes, sir.
What is this? What is this? Half h yn prime minus yn minus 1 prime.
Yes, sir.
Right? So finally, what will be that? On the left hand side, it is yn plus 1 minus yn. I will show this. I'm just telling that you must do that. Yn plus 1 minus yn equal to the first term, that is your yn. Sorry, yn prime term. Yn prime term is your hyn prime, right? Plus 1 by 2
h of yn prime minus yn minus 1
prime minus yn minus 1 prime. Y prime means what? It is f, that slope. So you
Yes,
just
sir.
rewrite it. So this here we have taken one more term, means it is the case corresponding to p equal to 1. So it is your yn plus 1. You take this yn on the other side, equals yn plus h yn prime plus 1 by 2 h yn prime minus yn minus 1 prime. This is the next method. What will be the order of this for p equal to 1?
It is an h.
No, pardon me, no, not like that. Local truncation error. If you see that which we have written earlier, let me go back. Then you will be able to understand. Oh, that next part wasn't there. So, okay, error term I will see separately. I will explain that. I will maybe if it is, I don't know whether it is possible today, but at least next term it will be possible. So this will be your for p equal to 1. Can you go for p equal to 2? Can you go for p equal to 2?
Yes, sir.
So it will be yn plus 1 equal to yn. Let me write that left hand side in this form, that yn plus 1 minus yn instead. I will write yn plus 1 equal to yn plus the first term hyn prime, right?
Yes, sir.
Then next,
Half h yn
so
prime
write
minus
down,
yn minus 1
write down
prime.
that, and so it will have del square of yn prime also.
Yes, sir. That will be 5 by 6 into h
5 by 12.
into del square of yn prime by
No,
2.
it should be 5 by 12. Check it.
Sir, 5 by 6 into 1 by 2. Yes, sir.
So 5 by 12, right?
Yes, sir. Yes.
5 by 12. And what is del square of your yn prime? So this is your del into del of yn prime.
Yes,
But yn prime is your, put the value yn prime minus yn minus 1 prime. So this will be del square yn prime will be what? Del yn prime minus del yn minus 1 prime. So what will be this finally? It will be, yes, tell me, yn prime minus 2 yn minus 1 prime plus yn minus 2 prime. Check that whether it is coming the same one. What is del square of yn prime? Only that term you tell me.
Yes, sir. Yn prime minus 2 yn minus 1 prime plus
That's
yn
it.
minus 2 prime.
Is that clear, Adrija?
Yes, sir.
Okay, good. So now I will close this slide, and again I will go to the another slide. Let me first open that. That was for p equal to 2. So combinedly just check that it is coming this way, that yn plus 1 equal to yn plus h by 12, 23 yn prime minus 16 yn minus 1 plus 5 yn minus 2 prime. Error term you leave that, I will explain separately. Whether this slide is visible to you, the another one?
Yes, sir.
Yes. That Adam-Basforth method, order 1, order 2, and so on and so forth.
Yes, sir.
Okay, nice. So this is what you wanted actually. So it was there as a pin. So this was the first, for p equal to 0 I have written, and that is your Euler method. Second, I have explained orally. So now I think I can talk a bit. Yn plus 1, Yn minus 1, Yn plus 1 minus Yn, it was on left hand side. So I have written on Yn, I have written on the right hand side, plus H gamma naught Yn prime plus gamma 1 del of Yn prime plus error term is there, that I will explain separately to you. Gamma naught is 1, you have already seen. Gamma 1 is half, you have already seen. Gamma 2, that it is required for error term, so that I will tell later on. So gamma n plus Yn plus 1 equal to Yn plus H Yn prime plus 1 by 2 of Yn prime minus Yn minus prime. This you have seen for p equal to 1, right? And so the method you have already seen, it has come like this, that Yn plus 1 equal to Yn plus, I think I haven't told you the combined one, that H by 2 3 Yn prime minus Yn minus 1 prime. There is one trouble with this method, that order 2 method. Can you see that? Just like your midpoint method, can you start this with y1? Can you get the value of
No,
y1 here? No. So you have to start for n equal to 1 at least. Means y2,
Yes.
it will start calculating y2 onward. So y1 we have to calculate from some other method. Y1 we have to calculate from some other method. Right? There is one thing which I would like to discuss here, and that I will explain later on, once we'll talk about the theoretical part. It is an order 2 method. So Y1, which order method you want to calculate? Now you have Taylor's method, at least second order, Runge-Kutta method, you have second order. So which order method? I'm not talking about Runge-Kutta or Taylor's method. Which order method you would like to calculate this Y1? I want answer from you people. Anybody?
First order.
No. Y1 I am talking. Where is Gauss-Seidel is coming with it? This is not implicit method. You see, okay, you write down this method. Write down this
We may
Yn
use
plus
the
1.
simplest method to like calculate y1. Euler method will be good then.
Why?
It is more simplest.
Is it no, that I used when there was no other second order method. You see, there is a point. It is a second order method, right? So if you calculate second order, suppose it is a first order method. What is the difference between a first order method and a second order method? In terms of the error, if
Error for the second order method is less compared to first order.
Right? Is that right? Now, another thing is that whatever the error we commit at suppose Yn stage, that error will get propagated to Y2, and then combining with the error in calculating your Y2 with your Y1 will be propagated to next one Y3 and so on and so forth. Is that clear or not?
Yes, sir.
Okay. Now, there are two types of error which I have already told. One is your round off error. So we are not talking about the round off error here. We are first talking about the local truncation error, right? We are talking about the local truncation error, which we are committing here, which we have the access to that immediately in a clear cut form. So since it is a second order method, we should calculate Y1 by
The second order method.
at least
like,
second order method.
yes,
Is that
sir.
right or not?
Yes, sir.
These values are called initial values. These values, we'll see that word, that these values are called initial values, that is Y1. For example, here it is Y1, which has to be calculated through some other method. And the common sense says that it should be of second order. Common sense is because this method is of second order. So the common sense is that this should be at least calculated through some second order method. Is that right or not?
Yes, sir.
But actually it is the other way. It is the other way. Once we'll talk about the theory, we'll see that with one less order even, if it is a second order method we are concerned, then with first order method itself, it provides a second order error in the final one. So if it is a fourth order method, suppose Adam-Basford fourth order method, then there may be several initial points which may be calculated by a third order method even. We need not to go further. That can be explained only through theory. It cannot be explained here actually. But here the common sense says that at least we should use second order method. So we just stick to this point. Next is your order 3 method is there. And then you can see I'm just gamma naught, gamma 1, gamma 2. You can calculate gamma 3. All these gammas you can calculate. These are just simple polynomials. So I'm not going to tell you. Up to del square yn minus yn prime, you have already calculated. So we will just put that and see the next method, how it looks like. Now you can calculate that because you require up to this error term. Right now you leave that. I will explain on the next term. So it is your yn plus 1. The next method is yn plus 1 equal to yn plus this thing. It has yn prime, yn minus 1 prime and yn minus 2 prime. So n equal to 0, it is not going to work. N equal to 1, it is not going to work because n minus 2 is also there, right? So yes, at least n should start from
2.
2 means what? You have to calculate y1 also, you have to calculate y2 also. You have to calculate y1 also, you have to calculate y2 also by some other method. Is that clear?
Yes, sir.
So this way you have several such methods of that Adam-Basford method, and then I'm coming back to this. So order 4 is there, and then some gamma values are listed here. Anyway, that you can calculate yourself, and you can verify that gamma naught you have already seen 1/2, and then gamma 2 will be 5/12, gamma 3 will be 3/8. And gamma 4 will be 251 by 720. Gamma 5 will be 95 by 288. So these values, so error part I will tell you later on. Remaining things are available here. Whether you people are able to download the files, okay, you check after that. You cannot check right now. So,
but like for this lecture, we have not got any files.
This one, this I wanted to upload today, but it wasn't possible to. So maybe I will send through if it is not possible today also. I mean after the class also. So maybe today or by tomorrow I will send that through ERP. But ERP was also not working today. So might be it is the institute server has some trouble. Because there was a power failure, sudden power flow, twice it was power failure. I think it was around 2:30 or so. So maybe it is because of that servers are not properly responding.
Yes, sir.
So this may be the reason. So as soon as either I will upload on the MS Team. That is what I was doing. I was trying to upload on MS Team, but even it was not allowing me to see the files which were already uploaded on that. So maybe the server here was creating trouble. I don't know.
Okay, sir.
Okay, so I will just change. Anyway, this is what. Anyway, I'm just take 1 or 2 points and then I will come back. Just for a moment, I am coming. Okay, for the next method, that is your Adams-Moulton method. There is a very slight change. Exactly the same thing. Y prime is integrated from xn to y prime equal to f is integrated from xn to xn plus 1. Again, the same yn plus 1 equal to yn plus integral xn to xn plus 1. F or y prime is there. We approximate this f or y prime by some interpolating polynomial. Now, the points we'll take here as follows. Let me first show the major part. These are some workings. Adams-Moulton methods. Here we'll take the points xn. There we have taken the point from xn minus p to xn. Here we just shift it. Means xn minus p minus 1 inside the bracket or xn minus p plus 1 to xn plus 1. Here we moved in that direction, forward direction. Here also we moved forward direction. Means the points are xn minus, instead of xn minus p, it is from xn minus p minus 1 to xn plus 1. Means xn is already included. So the only difference in Adams-Basforth method and Adams-Moulton method is that the interpolation done at one shifted points, means instead of xn minus p to xn, it is done on xn minus p minus 1 to xn plus 1. After that, everything is same. There is no difference in the working at all. So we'll use the points. So basically it is xn minus p, xn plus 1 we have written in the reverse order, xn plus 1, then xn and so on, xn minus p plus 1, or you may write xn minus inside the bracket p minus 1. Slide is visible or not? Hello?
It is visible, sir.
Okay. Now, so your PPT, that polynomial will be your yn plus 1. So it is the point, starting point is instead of yn, it is yn plus 1. So it is your yn plus 1 prime plus t minus xn plus 1 divided by h, backward operator yn plus 1 prime, and then t minus xn plus 1, one more one, that is next is your xn. So t minus xn divided by 2 factorial h squared, then here it is del square yn plus 1 prime, and so on. Next we'll have one more term, and so on and so forth. The last, as far as the method is concerned, we'll have one less point. One less point means it is up to xn minus p minus 1. So one less point it will have, means it is up to p minus 2 only. So xn minus p minus 2, that will be your t minus xn minus p plus 2. And the error term will have all the terms. So that is your t minus xn plus 1 to t minus xn minus p plus 1 divided by p plus 1 factorial, and then y prime p plus 1 derivative of y prime exactly the same way, because number of points are not different. The only thing, it is shifted. It is shifted. And now we'll just integrate it from xn to xn plus 1, all the individual terms, and then whatever comes, that will provide the method, basically your Adams-Moulton methods. Now, so I'm not going to discuss this in detail, because I have already discussed the Adams-Basforth method in detail, how to do the working of that. So instead of, still the hint is given, you write down t minus xn as hs. So t minus xn plus 1 will be your t minus xn plus h. So that can be written as h into s minus 1. So here the points will start 1, s, s 1, s, s minus 1, no, s minus 1, and then your the first term will be your, first term is your, where is that? First term will be your integral, your xn to xn plus 1, yn prime, and then mute your mic, yn prime, and then your dt is there, that will be changed to your h into ds, sorry, dt is h into ds, and then like that. So basically we'll get the following type of forms, that integral xn to xn plus 1 ppt dt, that will be h. I have written a delta j here instead of gamma j. A bit of difference is there. So points will be s minus 1, s, because you have seen the first point which you have, the product is here is your t minus xn, and t minus xn is your t minus, t minus xn plus 1, sorry. Here it is t minus xn plus 1. Next point is t minus xn. So let us see. T minus xn plus 1 is your h into s minus 1. So basically s minus 1 will be there. T minus xn, it is h into s, means s minus 1, s, and like that it will move s plus 1, and this way you can see that t minus, you just check that t minus xn minus 1, here it is written t minus xn minus 1. Xn minus 1 means, xn minus 1 means xn minus h, yes or no?
Yes, sir.
So t minus xn minus 1 will be what? T minus,
Minus xn minus h.
so it will be h into, no, not minus h.
It will be
Minus h
plus
is plus h, right? So it will be h into s plus 1. So first point is your s minus 1, second product will be your s, third product will be your s plus 1, and like that it will move. So here the delta j's will be like that. Delta naught, the very first one you have already seen, 0 to 1 ds. We see the first integral. First integral will be integral 0 to xn to xn plus 1, or I think that I have already taken. This will change to xn to xn plus 1, will change to 0 to 1, very obvious, that you have already seen. Then your 1 s minus 1. So the first term, if you see, first term is your this integral xn to xn minus xn to xn plus 1 dt, but dt is h into ds, xn to xn plus 1, that will change to 0 to 1. So this is nothing but your 0 to 1, and then ds. First term, second term will be your delta 1, that is your s minus 1. You keep this in mind. You put here 1 into s minus 1 ds. Delta 2 will be 1 into s minus 1 into s ds. You can calculate these values. This is not at all a problem. And then these values are as follows. This is your Adams-Moulton method. Fine. Gamma, the delta values I must be having somewhere. No, it is not given here. Anyway, you can calculate that. That is not a problem. So Adams-Moulton method, how it will look like. The way I have done, I have told you how to calculate your, how to write your Adams-Bashforth method exactly the same way. You have to write that y for p equal to 0, Adams-Moulton method will be yn plus 1 equal to y h times yn plus 1 prime. Error term, leave that. So if you see this one, this is what? Will this be an explicit method or implicit method?
Implicit.
Implicit method. So this Adams-Moulton method is, they are basically implicit methods. Adams-Bashforth methods are explicit methods. Is that clear?
Yes, sir.
Okay. I think I have already told the name of one book, numerical solution by numerical analysis by Atkinson, K.E. Atkinson. All these things are given in that book. The whole material is given in that book. So this part is taken from that book. And then for p equal to 1, you will find this method. This is called the trapezoidal method also, because of the average of yn plus 1 prime plus yn prime. Why it is called trapezoidal? You just see trapezoidal rule, what you do there. If you remember, what is the trapezoidal integral? Can anybody recall that? Can anybody recall that? 1 by 2 of first point value, last point value. Do you remember the trapezoidal rule? Trapezoidal rule for the integral?
No, sir.
Integral ft dt, x naught to xn if it is there. So this is your 1 by 2. This is your 1 by 2 of fx naught plus fx1
x naught minus x. I mean x1 minus x.
what is that?
X1 minus x2 f of
No.
x plus f of
How do you
x.
find how? No, not that way. It is 1 by 2 of fx naught, fx1 is there, fx2 is there, and then last term will be 1 by 2 of fxn. I'm not writing h and other things. How do you find the area of a trapezoid? Trapezoid, do you remember? Okay, you have to revise all those things. You have to revise all those things. Anyway, so the Adams-Bashforth, Adams-Boulton methods are written here up to your p equal to 3, and beyond that it will be quite high. Okay, next method is your Milne-Simpson method that I will tell you on the next turn. Let me explain the at least one method through one problem. So I will just close this slide. But the problem is seen on your screen. Find the solution at the point x equal to 0.3. Hello? This slide, any
Hello?
slide is seen. Any slide is seen on your screen? Adrija?
Yes, sir.
The lines are that find the solution at x equal to 0.3, 0.3.
Yes, sir.
Okay, fine. So now I can, because there are several screens coming, I am not able to understand that. So find the solution at this x equal to 0.3 for the differential equation y prime equal to x minus y square, y0 equal to 1, using this Adams-Bashforth method for of order 3. So it is your yn plus 1 equal to yn plus h by 2 3yn prime. You have already seen that 3yn prime minus yn minus 1 prime. Take this h as 0.1 and determine the starting values using your second order Runge-Kutta method. Second order Runge-Kutta method. So I'm leaving that as an exercise for calculating your y1 value. I have already explained how to calculate that, how to use your Runge-Kutta method. So K1 is your h times f of xn, yn. F is your, I think, what is it? X minus y square. x minus y square. So you can calculate your y1 using that, and then you can proceed further for your y2, because y2 can be calculated from y2 is your using your Adam-Basforth method. Y2 is your y1. Let me tell you, y2 will be your y2 will be your y1 plus h by 2 3 y1 prime minus y naught prime. How will you get y naught prime? Anybody? Anybody?
Sir, from y dash equal to
So
x
from
minus
the
1.
equation.
Exactly. Y
From-
prime equal to f. So y at the point x naught you have to just find out by putting x x as x naught, right?
Yes,
Yes,
sir.
yes.
So that what is the value? You write down the function f equals, or you write down the full differential y prime equal to your x minus y square, and y0 is 1.
Minus 1.
What is
Y
minus 1?
Y prime 0.
Acha, y prime 0 is your minus 1. Okay. So and y1 prime also you can find out without any trouble once y prime is given, right? At the point x1 you can calculate. So all the values on the right hand side you can calculate. Y1 is already known because from the your Range-Kutta method. So everything is known. You can get your y2. Similarly, here you have to get y2 prime also. Why you require y2 prime? For the next stage where you require, because y3 will be your y2, and then this h and other things are there, and then 3y2 prime minus y1 prime. So again your y2 prime is required, so you have to calculate y2 prime, and like that. So proceed further, you will get that. Now the trouble for your, then another method is there, that is your Adams-Moulton method, that is your implicit method. That is your implicit method. So at each stage you have to apply
Newton-Raphson method.
Newton-Raphson method. That's right. That's right. So I mean, today things are basically told in pieces. Still there are 2-3 things which are left. That is your I was not expecting even lecture also today. The way things were happening, I tried a lot to do things. The lecture notes were not able to upload there. So anyway, if it is not possible to upload on the that MS Team, I will send the PDF file to you people, all the PDF files related to today's lecture, and then error part will do maybe if it is possible I will take one lecture next week instead of only Wednesday. If it is possible I may take more than one lecture. So let us see that thing. I mean, it should not be too much to you people. That is the only thing I have to see. So first thing, you have to revise your interpolation. Otherwise, the derivation you won't be able to understand. Right? Is that clear?
Yes, sir.
Okay. This is all these methods are given in a different way in your book. That also I will tell you. That also I will tell you when I will start those things. That also I will tell you. That way also I will tell you in another. But you won't get the feeling there that how the method was developed. What was the basic thing? Why we are getting this? It is completely mechanical thing. Whether you people have the book or not.
Sir, could you please share the scanned pages of Jain and Iyengar, like you've sent some of the pages for the
No,
ruling.
that I don't have the scanned copy of Jan and Anger actually. Whatever you might have seen on the notes, in the notes, lecture note 2, earlier it was put there, but then I have done myself, the each and every line was done, because once I go to board, it is fine, I can explain the things there. But this online teaching, there is a trouble that, so I have each and every line, that was the thing, that implicit Range, second order Range Kutta method. That I have explained on the last term. So scanned copy, I don't have that book. Neither I have a scanned copy, nor I have the e-book also.
Yes, sir, that's why it was difficult finding that book on the internet.
I understand, but some of you people, I don't know how you get your senior batch people. They used to say they can get some PDF file somewhere on the net and something like that. So the book is not very costly book. The only thing, whether it is available to you people there or not. Hello.
Yes, sir. Yes, sir.
So
I
I don't know. So some of you may talk to some of your friends. If somebody is having, or maybe some of your senior is having. I never ask for those PDF files from your seniors. I never have asked. Otherwise, I would have forwarded to you people. So I don't have the copy of that. Neither, I mean, I have only hard copy. And that book is quite heavy, maybe 400, 500 pages. So it is not possible to scan unless until some particular part is required.
So like just for the numerical solution of ODE part, if it
No,
is
that's
possible.
too much. That book itself is quite heavy. That's what I'm telling. Numerical solutions of ODE is 400 pages or so.
Oh, sorry, sir. I thought there must be some
So,
other
no,
chapter.
no, it is not. It is not. You just try to, if you are in contact with some of your seniors, you people, then you just try, or maybe some of your friends might be having, just talk to them, right?
Yes.
Yes,
Hello, sir.
Yes, tell me.
Sir, I have it, means PDF file.
Okay, then you can share with your friends at least.
Okay, sir.
So that, I mean, you all can even solve the problems, and there are enough, you know that the nature of that anger book, that I mean, so many problems are there. Problem collection is very nice. Text part may not be very good, but at least problems are there, right?
Yes, sir.
So we will also upload some assignment. It is already in pipeline. We have to discuss certain things, and then how you have to submit these things. And that's the reason I used to ask you people, if you have any query, you ask me if it is possible to explain on the same day, because certain restrictions are there. I cannot write on somewhere. So once you tell the problem, I will do the problems completely and scan it, and either send to you, or put or upload on this MS Team and something like that. So, but nobody is responding. That is the they feel that online teaching means just fun. So you may miss, because this is the portion, the numerical analysis portion is very much important. Wherever you will go, does not matter whether you go to the academic institution for higher education, or you may go for your job, you may get to everywhere, starting from your satellite and other things, they are all going without numerical analysis, they cannot go. So, but it is up to you how much you want to learn. You see that in the beginning itself, one student, Vardhan, what was his name, Vardhan, he was more interested in attendance rather than I was asking the question, so it should not happen. This type of thing should not happen. Attendance is a different thing. You come in time, attendance will always be there without any trouble. So that is not at all a problem. So today's lecture, you just see, I will send the whichever way it is possible, send the PDF files. Okay, so today I will just leave at this stage because certain things I cannot do.
Okay, sir.
Somehow it is it was done today's lecture through his screen, the desktop screen, and so on and so forth. Okay, thank you.
Thank you, sir.
Thank you, sir.